Section 7.3 deals with indirect measurement using similar triangles. So set this into your table of contents, and then we'll start with the first example. Let's say in order to estimate the height of a tower, a tourist sights the top of the tower in a mirror that is on the ground and faces upward. How tall is the tower? Well, so this is a similar triangles problem. We know that the heights would be perpendicular, and the way mirrors work, we know that those two acute angles will be congruent. So that means these two triangles are similar by AA similarity. And since they're similar, we can set up proportions in order to solve for the unknown. We know that the ratio of the tower to person, in terms of their height, must equal the same ratio as the horizontal distances. So then we'll sub in the unknown and the known, and then we'll solve in the usual way using cross multiplication. So we get a height of 420.48. Now it's worth noting, when we set up these proportions, we did height divided by height equals horizontal distance divided by horizontal distance. Another correct way of setting up proportions would be to use the proportional parts within one triangle. So here on the left-hand side, we have the height of the tower divided by the horizontal distance of the tower. The height of the person equals the horizontal distance, height of the person divided by horizontal distance for the person. When you sub in your values, and you start solving, you see we have the same thing. So it's two ways to solve the same problem. Next, we have a person who is 5 foot 3 inches tall, and they cast a 6-foot shadow. At the same time of day, a lamppost casts a shadow that's 18 feet long. How tall is the lamppost? So we've got this lamppost. We know its shadow length is 18 feet. The height is unknown. And the person is 5¼ feet tall, and they cast a 6-foot shadow. These are similar triangles for the same reason that the previous one were similar, right, by AA similarity. And so we can set up our proportional parts. I know the height of the lamppost divided by height of the person must equal shadow of, I know it'll be shadow divided by shadow. Make sure that if you started on the left-hand side with lamppost on top, you have to keep your corresponding parts. So it has to be lamppost divided by person if you'd start off lamppost divided by person. And then we'll solve in the usual way. And so the lamppost is 15 feet 9 inches. And just to show you there's more than one way to solve this problem, if instead you solved it with the proportions of lamppost divided by lamppost equals person divided by person, you still get that same value of x. For the next example, I'm going to ask you to read it, draw a picture to the best of your ability, and solve it. We'll answer this question in class.